In this video, we're going to talk about the conservation of mass. The law of the conservation of mass tells us that during a chemical reaction, atoms are neither created nor destroyed. It is much like the idea of the law of conservation of energy, that energy could not be created nor destroyed, it could only be transferred. Well, the same thing is true about mass in a chemical reaction. What you start with, the amount that you start with, you have to end with that same amount of atoms. You can't destroy or create atoms out of nowhere. So in this equation, we're looking at hydrogen gas is reacting with oxygen gas. These are diatomic elements, remember, so they come in pairs. We can't just write H or O. And they react to form water, H2O. Now, if we look here, we can count the number of atoms on each side. We have hydrogen. There are 2 atoms of hydrogen, and oxygen on the reactant side, 2 atoms of oxygen. On the product side, after those 2 things react, we get hydrogen, and we have 2 atoms of hydrogen, and oxygen, where we only have 1 atom of oxygen. Now, we started with 2 hydrogen and 2 oxygen, and we ended with 2 hydrogen and 1 oxygen. So that means we just destroyed oxygen. That cannot happen. We cannot just randomly destroy an atom. We have to somehow figure out how they're going to react with each other and have enough atoms to fully react. So what we have to do is balance this equation. We're going to walk through that. The way that we balance equations is we use coefficients out front in order to balance this equation. So in this case, we would say, all right, hydrogen has 2 on both sides, so we're good. We only have 1 oxygen on the product side, so we need to add a coefficient out front so that we can have 2. Remember, the coefficient out front is just like a coefficient in math. You multiply everything that is after it by that number, the coefficient. So we would say, okay, 2 times 2 hydrogen, we're gonna have 4 hydrogen. 2 times 1 gives us 2 oxygen atoms. This basically means that we have 2 water molecules. Okay. Well, now we have 4 hydrogen, but only 2 on the reactant side. And so we're going to need a 2 over here. 2 times 2 gives us 4. And now we have equal numbers of atoms on the product side and the reactant side. So what does this mean? What does this look like? Well, this means that we have hydrogen, hydrogen. We have 2 hydrogen molecules, and 1 oxygen molecule is going to produce 2 water molecules. And you can see here that we have 1, 2 oxygen, 1, 2 oxygen. And then we have 1, 2, 3, 4 hydrogen, 1, 2, 3, 4 hydrogen. The coefficients out front tell us how many molecules of each reactant we have and how many molecules of each product we have. So the law of conservation of mass tells us that mass is neither created nor destroyed in a chemical reaction, and then the numbers of atoms on the left side or the the reactant side of an equation must equal the number of atoms on the right side or the product side of the equation in order to obey this mass conservation. So let's look at this equation here for counting atoms. How are we going to determine how many atoms of product and how many atoms reactants we have? So here we have tin oxide plus hydrogen gas is going to produce tin plus water. Now, the 2's that are blue are subscripts. Those tell us how many of each atom we have. The coefficient is red. The coefficient is going to tell us how many of that molecule that we have. So how many water molecules we have. Here we have 2 water molecules, or here we have 2 hydrogen molecules. The coefficient can be changed, but the subscripts cannot be changed of a formula. If you change the subscript of a formula, you are going to change the identity of a substance. So that if we say CO versus CO2, right, this is carbon monoxide. It is poisonous, right? Carbon dioxide, we breathe out, plants breathe in. The other thing would be water, right? Or Hydrogen peroxide. We changed a 1 to a 2 here. This is water. We drink that and it helps us survive. Hydrogen peroxide is poisonous if you drink it. So you cannot change the subscripts. It changes the identity of the molecule, but you can change the coefficients. A coefficient functions just like it does in math, and you multiply everything after it by that number until you get to a new molecule. So in this case, we can count our atoms here, and we have tin, oxygen, and hydrogen on the reactant side. We have 1 tin molecule, we have 2 oxygen atoms, 1 tin atom, 2 oxygen atoms, and we have a 2 coefficient in front of a hydrogen that has a 2 subscript. So we have basically 2 hydrogen molecules, which means we have 2 times 2, which is 4. The coefficient will multiply by all the subscripts. 4 atoms of hydrogen. On the product side, we have tin, oxygen, and hydrogen as well. That's good. We didn't create any new atoms. On the product side, we have 1 tin, and then we have 2 water molecules, right? We have 2 water molecules like this. And so we have 2 times 2, we have 4 hydrogens, and 2 times 1 gives us 2 oxygen. And we can see that atoms were not created or destroyed. We have equal numbers on both sides. Let's look at a couple of other examples. We have carbon plus oxygen gas is going to produce carbon monoxide. Okay. We have on the reactant side carbon and oxygen. We have 1 carbon, 2 oxygen. On the product side, we have carbon and oxygen. We have 1 carbon and 1 oxygen. Let's check our carbons first. Our carbons match. Then we're going to check our oxygens. We have 1 more oxygen on our reactants than on our products, and so we need to add a coefficient of 2, right? We can't add a 2 here because that makes carbon dioxide, which is a totally different substance. Okay, so we have to add a coefficient of 2. You can only add coefficients when you are balancing equations. So 2 times 1 gives me 2, 2 times 0, or 2 times 0, 2 times oxygen, 2 times 1 for oxygen gives me 2 oxygen. Well, now I have too many carbon on the product side, so I need to add a 2 coefficient to the reactant side. So 2 times 1 gives me 2 carbon. Doesn't change oxygen at all because the coefficient in front of oxygen is still 1, right? If there's nothing written there, we assume it's a 1. And so we have 2, and those balance. So that's how we would write this balanced equation. You do not have to write this 1 here. If there is nothing written in front, we assume that it is a 1. So you'll typically see this written as that. Okay, let's try a couple more. Okay, we have iron plus chlorine is going to provide or yield iron 3 chloride. Okay, so we have iron and chlorine and iron and chlorine. Let's see, on this side we have 1 iron. On this side, on the reactant side, we have 2 chlorine. On the product side, we have 1 iron. On the reactant side, we have 3 chlorine. All right, so our iron are balanced, our chlorine are not. So here we have 2 chlorine and 3 on the other side. Well, I can't just make this a 3, so I'm going to have to multiply this by a number. Now, what I want to do is I want to find the number that is a common multiple of both 2 and 3. And so 2 and 3, the common multiple would be 6, not 4, right? And so I'm going to multiply this by 3 here so I can get 6 chlorine. If I go to the other side, then I'm going to have to multiply this iron chloride by 2. Now I can't just multiply chlorine by 2. I have to multiply the entire molecule by 2, right? I can't just put a coefficient here. I have to put it out in front of the entire molecule. And so that's going to change the number of irons I have, but that's all right. So now I have 2 irons and 6 chlorine. Well, now our chlorine are balanced, but we have to balance our irons now. And we will just put a coefficient of 2 in front of iron so that we have the same number on the product side as we do on the reactant side. Let's try one more difficult one. H2SO4 plus KOH produces H2O plus K2SO4. All right, so on the reactant side, we have hydrogen, we have sulfur, we have oxygen, and we have potassium. I hope I have those same things on the other side. I like to write them in the same order on both sides of the equation, both the products and the reactants, so that I can directly compare them and I don't get them mixed up. So let's count the number of hydrogens on the entire side of the reactants. We have we have 2 hydrogens here, and we have 1 hydrogen here, so we have a total of 3 hydrogens on this side of the equation. We have 1 sulfur, and we have 4 oxygens here and 1 oxygen here, which will give us 5 oxygens. We have 1 potassium. Let's count them on the product side. All right, we have 2 hydrogens. We have 1, 2, 3, 4, 5 oxygens. We have 1 sulfur, and we have 2 potassium. Okay. So when you have equations like this, you want to keep your oxygens and your hydrogens for last because they appear in both substances on either side of the equation. They appear both as reactants and as products. Okay, so we're going to first balance anything that's not hydrogen and oxygen. And we find that we have 2 potassium on the products and 1 potassium on the reactants. So I need to multiply KOH, potassium hydroxide, by 2 so I can get 2 potassium. Now that's going to change the number of oxygens and hydrogens I have, right? So I have 2 hydrogens here, plus 2 is going to give me 4 hydrogens. 4 oxygen plus 2 oxygen is going to give me 6 oxygen. If I go to the other side, you can see that I have, so now that has balanced my potassium, but has thrown a few other things out of whack. Our sulfurs are okay for now, but we need to change the number of hydrogens and oxygens that we have. Now we have 4 hydrogen on the reactant side, 2 on the product side, 6 hydrogen on the reactant side, and 5. So if I multiply my water by 2, that's going to balance out my hydrogens. I'm going to have 2 times 2 gives me 4. And my oxygens, I'm going to have 2 times 1 is 2, plus 4 is going to give me 6. And now my equation is balanced. So here are some rules for balancing chemical reactions. In chemical reactions, balancing is all about finding the right coefficients. You can change the coefficients, but you can never change the subscripts. So the subscripts are always off limits. You cannot change the subscripts. You can only change the coefficients out front. The coefficients must reduce to represent the lowest possible numbers. So here we have a coefficient of 4, 2, and 4. These all can be divided by 2. And so the actual way that you would write the balanced equation would be 2, 1, 2, because they all can be divided by 2. You want to represent the lowest possible numbers. It's okay to use fraction coefficients, but you must get rid of them in the end by multiplying through by the denominator. So if you use a fraction coefficient here of 1/2, at the end you'd have to multiply everything by this denominator, which is 2, to get rid of that fraction. So you'd have 2H2 plus 2 times 1/2, which would give you 1, O2, 2H2O. And so you'd write 2H2 plus 1O2 gives you 2H2O. Often it's really helpful to save hydrogen, carbon, and oxygen until the very end. Really, oxygen is usually the last one that you are going to alter until in your balanced equation. So you want to start with your metals, and then you'll go to other nonmetals that are not C, O, and H, and then you will balance C, O, and H. And then you can do a final balance check for each element. So at the very end, you should go back and say, okay, hydrogen, I have 4, oxygen, I have 2, hydrogen, I have 4, oxygen, I have 2. So here are some more practice problems for you. Again, these boxes all changed my arrows. They're supposed to be arrows in between here. So you can try these out as well as the other practice that you have.